So are we live? Let's check it out on our channel, The Code Specialist. Um, let the thing load. What are we sharing? We are not live, it seems. Let's wait few seconds. Uh, what are we sharing today? Let's go for Brave Detective. Yes, this is the one. Today's question quite simple. Might get complete in few minutes of time. Uh, Is there something else I should be sharing with you all? Um, let me do this. Wait a minute. Mm, control shift, control new YouTube. Yes, we are live. Wait a minute. List. So are we live? Let's check it out on our channel, The Code Specialist. Um, so we are live, but the broadcasting setup is quite useless. Mm, so can't help with that. Let me show you the whole screen. So to grow we must suffer.
The only way you're ever going to get to the other side of this journey is you have got to suffer to grow. To grow, you must suffer. Some people will get it, some people won't.
That you have to do those things. You have to suffer, you have to live in it, you have to be comfortable in it. Because if I just think, well, tomorrow I'm just gonna coast and eat Twinkies and watch TV. Oh, hello, sadness, my old friend. Hello, depression. Because when you're not doing anything, you feel like shit. And that's just part of being a human being. And we can pretend that we're something other than what we really are. And we can pretend, nah, me, man, I'm just cool, just chilling, doing nothing. Bullshit.
Takes more effort to start in the beginning, and more people are right about the fact they're like, hey, you're not going to hit it big. And guess what? A month in, you're not. But they're only measuring on months. And at 6 months, you're also not going to have hit it big yet. And they're going to be like, I'm still fucking right. And at a year, you're still not going to have hit it big. And they'll still be fucking right. And every day that you haven't hit it, they're going to feel like they were right. But they're wrong. Because they're measuring in days and you're measuring in decades.
You stay in your comfort zone, that's where you will fail. You will fail in your comfort zone. Success is not a comfortable procedure. It is a very uncomfortable thing to attempt. So you got
In life there is suffering. If we want an easy life, we dream of an easy life. There is nothing that going to be an outcome of it. So by dreaming you are not going to get an easy life. To enjoy the life, you can dream big. You can act on it. And while enjoying the life, you will feel that this is what I wanted and hence feel satisfied. Asking for easy life, you will never feel satisfied because you will never achieve anything.
to get comfortable being uncomfortable if you ever want to be successful.
We need adversity, we need difficulty.
So let's understand few things about Docker today.
Welcome to Docker 101. If your goal is to ship software in the real world, one of the most powerful concepts to understand is containerization. When developing locally, it solves the age-old problem of it works on my machine, and when deploying in the cloud,
Almost all the problems, which mean the videos based on Docker, are something like that what we say starts with the same old thing. It works on my machine, but it doesn't work on yours. What was
software
the
in the real world, one of the most powerful
saying?
concepts to understand is containerization. When developing locally, it solves the age-old problem of it works on my machine, and when
This old problem has given so many views to so many content creators. I have also made one blog on it. Has no.
If you're
Mm, what else can we learn today? Okay, this much is enough, I feel so.
when deploying in the cloud, it solves the age-old problem of this architecture doesn't scale. Over the next few minutes, we'll unlock the power inside this container by learning 101 different concepts and terms related to
Docker
computer
version.
science, the cloud, and of course Docker. I'm guessing you know what a computer is, right? It's a box that has three important components inside: a CPU for calculating things, random access memory for the applications you're using right now, and a disk to store things you might use later. This
I mean, my prerequisite part 1 also says the same thing, that what is virtualization, what is virtual machine, what is hypervisor, and how they divide the physical hardware structure into multiple virtual environments. Where's the diagram? This is the diagram I have created. Uh, Canva is a great tool. Here there are two types of hypervisor: native or bare metal, or hosted or embedded. In native, the hardware is for single hardware. There is no another layer of operating system. Direct, there is a hypervisor which manages multiple virtual machines. So here one layer of complexity gets removed, but this is our regular developer experience. This is our server experience. So how server works when there is no need for user interface and all, using operating system. So what is Fireship going to teach us something
This
new?
is bare metal hardware, but in order to use it, we need an operating system. Most importantly, the OS provides a kernel that sits on top of the bare metal, allowing software applications to run on it. In the olden days, you would go to the store and buy software to physically install it on your machine. But nowadays, most software is delivered via the internet through the magic of networking. When you watch a YouTube video, your computer is called the client, but you and billions of other users are getting that data from remote computers called servers. When an app starts reaching millions of people, weird things begin to happen. The CPU becomes exhausted handling all the incoming requests, disk I/O slows down, network bandwidth gets maxed out, and the database becomes too large to query effectively. On top of that, you wrote some garbage code that's causing race conditions, memory leaks, and unhandled errors that will eventually grind your server to a halt. The big question is, how do we scale our infrastructure? A server can scale up in two ways: vertically or horizontally. To scale vertically, you take your one server and increase its RAM and CPU. This can take you pretty far, but eventually you hit a ceiling. The other option is to scale horizontally, where you distribute your code to multiple smaller servers, which are often broken down into microservices that can run and scale independently.
Yes, so the vertical scaling creates a monolithic application. So m- able to debug and manage by, by a greater team can cause a greater means, so the updation part would take more efforts, because if some people are working on same service, and during the merge there are two different branches forming, so every time they would have to solve the merge conflict error.
You take your one server and increase its RAM in smaller servers, which are often broken down into microservices that can run and scale independently. But distributed systems like this aren't very practical when talking about bare metal, because actual resource allocation varies. One way engineers address this is with virtual machines, using tools like Hypervisor. It can isolate and run multiple operating systems on a single machine. That helps, but a VM's allocation of CPU and memory is still fixed, and that's where Docker comes in. The sponsor of today's video. Applications running on top of the Docker engine all share the same host operating system kernel and use resources dynamically based on their needs. Under the hood, Docker's running a daemon or persistent process that makes all this magic possible and gives us OS level virtualization. What's awesome is that any developer can easily harness this power by simply installing Docker Desktop. It allows you to develop software.
So in my later parts, mm, installation is okay. Docker commands, Docker architecture. Docker daemon. I have talked about Docker daemon and Docker D. So Docker daemon is the server and Docker is the command line or client interface. Sorry, Docker is the server which communicates using client-server architecture, gRPC communication, uh, high-performance remote procedure call frame. Okay, for in server communication, gRPC and REST API is used for client-server communication. Okay, so Docker D or Docker D.
Software without having to make massive changes to your local system. But here's how Docker works in 3 easy steps. First, you start with a Docker file. This is like a blueprint that tells Docker how to configure the environment that runs your application. The Docker file is then used to build an image, which contains an OS, your dependencies, and your code, like a template.
Okay, so Docker file is based upon previously created Docker images. So most of the time, if you are running a web server, you might require a Linux operating system or something like that. So see, first we have initialized our base using Debian. Then we are selecting the working directory, and here he is using Python. So he will get or install Python and all, then copy the local server script to container. Okay. This is his command, python 3 http server 80. So I have also done something like that. See all architectures done, creating a custom image, this way. But I have done using React app as well as Next.js. Where is my Next.js one? I am not able to find it, but most probably after React app should be Next.js. Acha, no, this is public it. Mm, Control like next. Unable to find it. Volume custom Docker image. So I have not done most probably Next.js app because in my repository, where is it? Docker Next.js. I have done it. Why is it not there? So first we will require a clean working directory, then a React project, Docker file. I've used Alpine, create user permission to run app. Okay, set user to run the app, set working directly, copy the packet.json from working directly. Sometimes the ownership. Okay, so this is for ownership. All now and the dependencies are installed, exposing this port, and then our command of running a React application run dev. Build options. Quite in detail, I have referred JavaScript mastery, very good resources.
Environment that runs your application. The Docker file is then used to build an image, which this is like a blueprint that tells Docker how to configure the environment that runs your application. The Docker file is then used to build an image, which contains an OS, your dependencies, and your code, like a template for running your application. And we can upload this image to the cloud to places like Docker Hub and share it with the world. But an image by itself doesn't do anything. You need to run it as a container, which itself is an isolated package running your code that in theory could scale infinitely in the cloud. Containers are stateless, which means when they shut down, all the data inside them is lost. But that makes them portable, and they can run on every major cloud platform without vendor lock-in. Pretty cool, but the best way to learn Docker is to actually run a container. Let's do that right now by creating a Docker file. A Docker file contains a collection of instructions, which by convention are in all caps. From is usually the first instruction you'll see, which points to a base image to get started. This will often be a Linux distro, and may be followed by a colon, which is an optional image tag, and in this case specifies the version of the OS. Next, we have the working directory working directory. Next, we can use the run instruction to use a Linux package manager to install our dependencies. Run lets you run any command just like you would from the command line. Currently, we're running as the root user, but for better security, we could also create a non-root user with the user instruction. Now we can use copy to copy the code on our local machine over to the image. You're halfway there. Let's take a brief intermission. Now to run this code, we have an API key, which we can set as an environment variable with the env instruction. We're building a web server that people can connect to, which requires a port for external traffic. Use the expose instruction to make that port accessible. Finally, that brings us to the command instruction, which is the command you want to run when starting up a container. In this case, it will run our web server. There can only be one command per container, although you might also add an entry point, allowing you to pass arguments to the command when you run it. Run our web server. There can only be one command per container, although you might also add an entry point, allowing you to pass arguments to the command when you run it. That's everything we need for the Docker file. But as an added touch, we could also use label to add some extra metadata, or we could run a health check to make sure it's running properly, or if the container needs to store data that's going to be used later or be used by multiple containers, we could mount a volume to it with a persistent
Yes, this is very important using volume.
disk. Okay, we have a Docker file, so now what? When you install Docker Desktop,
What happens is we can communicate multiple containers using one persistent data storage using definition of volume.
that also installed the Docker CLI, which you can run from the terminal. Run Docker help to see all the possible commands, but the one we need right now is Docker build, which will turn this Docker file into an image. When you run the command, it's a good idea to use the T flag to tag it with a recognizable name. Notice how it builds the image in layers. Every layer is identified by a SHA-256 hash, which means if you modify your Docker file, each layer will be cached, so it only has to rebuild what is actually changed, and that makes your workflow as a developer far more efficient. In addition, it's important to point out that sometimes you don't want certain files to end up in a Docker image, in which case you can add them to the Docker ignore file to exclude them from the actual files that get copied there. Now open Docker Desktop and view the image there. Not only does it give us a detailed breakdown, but thanks to Docker Scout, we're able to proactively identify any security vulnerabilities for each layer of the image. It works by extracting the software bill of material from the image and compares it to a bunch of security advisory databases. When there's a match, it's given a severity rating, so you can prioritize your security efforts. But now the time has finally come to run a container. We can accomplish that by simply clicking on the run button. Under the hood, it executes the Docker run command, and we can now access our server on localhost. In addition, we can see the running container here in Docker Desktop, which is the equivalent to the Docker pst command, which you can run from the terminal to get a breakdown of all the running and stock containers on your machine. If we click on it though, we can inspect the logs from this container, or view the file system, and we can even execute commands directly inside the running container. Now, when it comes time to shut it down, we can use Docker stop to stop it gracefully, or Docker kill to forcefully stop it. You can still see the shutdown container here in the UI, or use remove to get rid of it. But now you might want to run your container in the cloud. Docker push will upload your image to a remote registry, where it can then run on a cloud like AWS with Elastic Container Service, or it can be launched on serverless platforms like Google Cloud Run. Conversely, you may want to use someone else's Docker image, which can be downloaded from the cloud with Docker Pull. And now you can run any developer's code without having to make any changes to your local environment or machine. Congratulations, you're now a bona fide and certified Docker expert. I hereby grant you permission to print out the certificate and bring it to your next job interview. But Docker itself is only the beginning. There's a good chance your application has more than one service, in which case you'll want to know about Docker Compose, a tool for managing multi-container applications. It allows you to define multiple applications and their Docker images in a single YAML file, like a front end, a back end, and a database. The Docker Compose up command will spin up all the containers simultaneously, while the down command will stop them. That works on an individual server, but once you reach massive scale, you'll likely need an orchestration tool like Kubernetes to run and manage containers all over the world. It works like this. You have a control plane that exposes an API that can manage the cluster.
Sorry, I had what we say trance. I have zoomed out. I was thinking what to say about Docker Compose. So Docker Compose allows managing multiple containers, which also in turn allows creation of containers one after another. So if this container is not built, this database container can also be halted until creation of backend.
Is in a single YAML file, like a front end, a back end, and a database. The Docker Compose up command will spin up all the containers simultaneously, while the down command will stop them. That works on an individual server, but once you reach massive scale, you'll likely need an orchestration tool like Kubernetes.
This is individual servers, we will require orchestration tool. Okay, so what was he trying to say? There were 3 servers in it. It was within one PC, I think so. So if on multiple devices, something like that.
Kubernetes to run and manage containers all over the world. It works like this. You have a control plane that exposes an API that can manage the cluster. Now the cluster has multiple nodes or machines, each one containing a kubelet and multiple pods. A pod is the minimum deployable unit in Kubernetes, which itself has one or more containers inside of it. What makes Kubernetes so effective is that you can describe the desired state of the system, and it will automatically scale up or scale down, while also providing fault tolerance to automatically heal if one of your servers goes down. It gets pretty complicated, but the good news is that you probably don't need Kubernetes. It was developed at Google based on its Borg system, and is really only necessary for highly complex, high traffic systems. If that sounds like you though, you can also use extensions on Docker Desktop to debug your pods. And with that, we've looked at 100 concepts related to containerization. Big shout out to Docker for making this video possible. Thanks for watching, and I will see you in the next one.
Quite an overkill. I mean, I wanted to do workout, but my development journey doesn't allow me to. Because if I went for college, my whole day would be exhausted and not able to complete my coding task. And if I'm at home, I don't like to waste my time. So currently can't able to do.
Studying for coding interviews, you've got to know backtracking. We can use backtracking to solve the permutation problem, where you have all possible orderings of a list of numbers. Let's generate all permutations of 1, 2, 3. The first number could be either 1, 2, or 3. Then if we picked 1 as the first number, you could have 1, 2, or 1, 3. You could have 2, 1, or 2, 3. Each of the leaves at the bottom are a permutation of 1, 2, 3. Our code is going to use backtracking to go through all of these possibilities. So we're going to build up solution which starts at empty, and we're going to eventually make it one full permutation. We're going to go through all of the numbers, and for every number that's not in the solution, we are going to append that number to the solution. After we've made this decision, we want to call backtrack, which does this recursively. But after we call backtrack, we must undo what we did. We take that number out of the solution. We are going to go back up the tree. As soon as we get that the length of the numbers is equal to the length of our solution, we want to append to our full list of permutations that we have a solution. And so that's why if you're studying for coding
Or in
interviews, you've got
if not in solution. So what does num
to know backtracking. We can use backtracking to solve the permutation problem, where you have all this easy algorithm. If you're studying for this easy, if you're
where is num? Where is num? अच्छा, it's in the parameter. So 1, 2, 3. If they have given 1, 2, 3, something like that. Okay. So let me show you my permutation example for Java. Permute all possible what? Permutation. Yes. So I'm also using an array list to contain all the possible permutations. Here ABCDs are used. Not a big problem. So what we will do is use processed unprocessed method. So how does that go? We are left with a empty string and C, E, and A. So we will have a for loop calling unprocessed length. So this is unprocessed. So it will call all the 3 times. So what will happen is we'll call C over here, then BA remains. Now I will call B over here, CA remains. Why is this text getting omitted? Now I will call A and CB remains. After this, let's create a line for C, for B and A. Now C and A. C and B. So let's call text. This we'll call CB and A. This we'll call CA and B. Are they? You are given a string point. The order of permutation doesn't matter. Okay. So this is a good sign for us. Or else we have to sort this ABC and do now B will be there with C, B, C, and again we will call what B, A, then C, C is there. So we'll continuously do this. Should I write? I'm getting bored. A, C, then B, A, B, and C. So what here it will come in the next call CBA, CAB, and all of that. So what is our time complexity? This was my main concern. So here the length was three calls are made. So for every n calls are made, and what is the depth? It is again of n length. 1, 2 and 3 again. So n square is the time complexity according to me. Space complexity would be again n, because till here the whole array, what we say, is going to be present in the call stack. So n again over here. So let's call SDE sheet. What is in SDE sheet? Recursion. Yes, in recursion, rate of permutation. I'm just seeing what he has provided. N factorial O of n space. Using backtracking, n factorial n. Is mine and his solution the same? Not quite. Okay, so this is the back end. Our might be recursive solution. Where is our solution? Yes, our recursion. How he is saying n factorial? All possible permutation are n factorial. Okay, so 3, then 1, 2, 3, 4, 5, 6 permutation. Has he provided explanation? No, he has not.
Hey everyone, welcome back to the channel. I can pick because so when you go back, please make sure you unmark it. So this will be unmarked. So can I say this is the data structure? Data structure will have two back. So when you get back, so that you picking up 1, 3 over here. Over here, I was limited to picking up 1, 2. Over here, I'm actually using a something, ignore 0 to take and 2. If I talk about the time complexity, what's the time complexity? I know there is n factorial permutations that I'm generating. So I'm going to take an n factorial time, and I'm looping every time from 0 to n. So that's taking a big O of n time. The time complexity is n factorial into n. What is the space complexity? If I ignore this answer, which stores n factorial permutations, if I ignore that, what is the space complexity? I can say I'm using a big O of n that stores this data structure, and I can also say I'm using a big O of n for this map array, right? So over here, I'm actually using something like a map.
So if we are going to see for entire current process, 3 calls are being made. Okay, how many times will it go on? N factorial times. Let me think about it. For every n, so if our length is 3, so 3 into 3 9. N factorial is causing 6 into 3. What is 3? 6 3 is 18. Yes. So how many calls are being made? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So around 18 calls in worst case. Means this is the worst case. I feel it is n into n because अनप्रोसेस्ड का लेंथ है 3 बार हम लोग ने ये लूप कॉल किया और फिर अनप्रोसेस्ड का लेंथ हुआ then is this creating factorial? Yes it is. Yes it is n factorial n. It is n factorial n. Space complexity will be n. Okay, let's just exit it.
This easy algorithm is one of the most important for coding interviews. Suppose we were given any linked list and we wanted to return the node in the middle. The obvious thing to do is to traverse the list and then get its length, but that's not why Google asks this question. The trick is to use a fast and slow pointer, both pointing to the head, and
So in our previous what we say, the code, I have solved this middle element problem. Mm, Where is it? I have not done it. Where is delete, add two numbers, remove nth node, merge, find? Yes, see, find the middle. Yes, I put on this. So quite simple, fast and slow pointer as he said. Mm, You can check it out on my live stream, and Now let's concentrate on our today's topic. So let me prevent sharing the whole screen and understand the question. Detect the loop. So how this will work? First we will start the timer. The second step of our drill is to use the marker. Given a linked list and node, the task is to check if linked list has loop. List can contain self loop. So X is giving the position where it is connected. Okay. I mean the explanation part I feel I will do on the pen and paper and understand that complexity, optimal approach, all of this is better on pen and paper according to me. So nothing to lose. Let's get things started. So little bit time is being taken for setup. So today I was unable to set up my what we say desk. I was in a hurry to do this what we say stream, so the setup was incomplete. My only concern is, are you able to see it? Most probably yes. Detect cycle. Should I check it on our channel? Might take few seconds, but result optimal video quality cycle. No, this is not. Should I check it on our? How can I improve this channel? Might take me bring out the big boy. Result optimal video quality cycle. No, this is not. Should I check it on our? How can I improve this channel? Might take me bring out the big boy. Result optimal video quality cycle. No, this is not. Should I check it on our? How can I improve this channel? Might take me bring out the big boy. Result optimal video quality. Let's say the name of God and move ahead. Jai Shri Ram, Jai Hanuman, Jai Marvel. It on our. What example should I take? How can I improve this channel? So the example might look like something out of sci-fi movie. So this is it, how we begin. What we have to check, if there is a self-looping element in the linked list. Since 3 is the starting point of it, are they asking us to return the point? Uh, no, it's just a boolean. So what might the brute force? Hmm, First of all, we will require a hash map for it. Why a hash map, you might ask? Because we will store all the elements in the linked list, and if the hash map occurs another object of linked list with which is present in map, it results in us getting confirmation that what we say, the map contains a so let's create a map. This is just a counter which are storing along with it. So after the whole traversal, this might be created, and our position would look like this. We are again coming out here from here to this, then to this, then to this, then to this, and to this. On reaching out over here, since the object is already present in it, results in what we say, in satisfying a if condition where we were continuously checking if the node is stored in the hash map or not. Since it is present, we will return true. So what the time complexity out here would be, time complexity O of n. Quite simple. Why? Because we are iterating the whole list for one twice. Space complexity will be again O of n because we are storing all the elements into the linked list. Brute force done. What is this? Optimal. Quite simple out here again. We are using fast and slow pointer. Why so? Because one of the properties or use case of fast and slow pointer is for cycle detection. So how this works, let me do a detailed dry run for this. One, I'm directly jumping to 3, 4, then 5. Slow and fast pointer are pointing out at here. After the first iteration, it will look something like this. Slow will be out here, fast will be out here. On the second iteration, should I do it here or here? It's not a big thing, man. Do it wherever you feel, man. slow will come out here. Now it's over here. Fast was over here. So dot next. It will be over here. Now on the third iteration, are you able to see it?
as
On the shift tab, control shift T.
role, and
Mm,
there I was working on
it will be
developing a new
over
cloud
here.
service from scratch, right? And then earlier to that, I have also worked as a SD2 and PayPal. So PayPal is a payments company. Everybody might be
Am I
aware
right
about that. They
over
call it the PayPal
till
Mafia,
here?
where
See,
Elon Musk
fast
was the
has come
founder.
here.
So there also
Another
I have
next
worked
dot
as an
next is over
SD2,
here.
right? And
Yes,
that profile was
I
kind of a full
think
stack
so.
role. So where I was working in the payment gateway team of the PayPal,
One,
right?
three,
And prior to that, I have
five,
worked with
four.
Nagarro. So Nagarro is a service-based company, right? And prior to that, I
So
started my work with Indus Valley
slow was
like
out
Partners.
here.
So
Now
Indus
it
Valley
will come.
Partners was a campus placement for me, right? And the company was into hedge fund and
Here,
trading. So they used to
fast
kind
dot
of
next dot
work in
next.
the
Since
with
here
all the
is
hedge
an
funds around the
interaction,
world, and they used to develop trading strategies, right?
it
So it was
gives a
more of a
hint
quantitative
that
developer role, and that profile actually came
the
to our
presence
kind
of
of
a
campus,
cycle
and
is
I was
here.
fortunate enough to get selected in that.
Oh my god, this me that uh, it was going to eventually meet the fast and slow water. So the time complexity out here would be O of n again. Even though iterations might be quite many, not many, but see, might sell the whole thing again, the fast pointer. But that much we can ignore. Space complexity is what we say constant because we are just using two pointers, slow and fast. Nothing else, nothing to store or as auxiliary space, nothing such. So let's jump into implementation part. So how we will begin? Should I do the hash map version? Hash map. Oh my god, dogs are barking. Uh, there's nothing wrong in doing it. So let's jump into it. Hash map node comma what else? Integer map is equals to new hash map. So the expected time complexity was fed. Since we are using hash map, the second condition might not be reached, but this is the brute force. While so first we will require another temporary variable is equals to head while temp not. So what we will do is if map dot contains key temp dot data return true. This is one check which will allow to loop out After infinite cycle, the loop would be creating, the cycle would be creating. So if it is not, temp is equals to temp dot next. But before this, all the elements map dot put temp comma not key node. We are checking for node, not data. Temp dot put temp array map dot put temp and count of 1. It should not fail, man, because of space complexity. So this was one of the solution. Another solution is node temp is equals to not temp though. What will be the condition? While slow not equals to null and fast not equals to null. But what the condition will be, we will do it in if. I mean, I should have put fast in the front seat because possibility of fast getting null is higher than the possibility if of slow becoming null. Else we will return false. What we will be doing is just looping fast dot next dot next. Slow is equals to slow dot next. Is it the case or I'm missing thing? This is only the case. Quite simple question. Oh my god, what in the world is this? Where I am missing the point. Let me think. Fast and slow pointers have been initialized. What else? While fast not equals to okay. Here, rather than checking slow, we will check fast and fast dot next. Again the same error. See, your code does not work correctly for multiple testing. The first case was okay. Okay. This will always return true, man, because at the first position, slow and fast are pointing at head. So the check should be later on. Just submit and complete it, man. I don't like waiting and all. Fast and faster, man. Go faster. Yes. 4 attempts. It's giving me a headache, man. Can't do anything about it. Another easy question done. Let's rock and roll in the upcoming live stream. Till then, bye guys.